and welcome to a video tutorial on two-variable linear inequalities. We're going to take some time to introduce two-variable linear inequalities, and what I want to do is actually compare what we've learned before with linear equations and get us thinking about linear inequalities in the sense of two variables x and y. So on the left side, we're going to make this equations, and on the right side, we're going to deal with inequalities. All right, let's start off with a nice equation. We've learned about linear equations in slope-intercept form. That's y equals mx plus b. We've also learned about linear equations in standard form, ax plus by equals c. And again, we spent time about how to rearrange them in different forms. But they're equations. That's equal to. That's what we have going on. But they're linear in that they're sharing both x and y. And there's two variables, and we're seeing if I change x, what happens in response to y. We learned how to evaluate, we learned how to solve equations, and just work with these things, trying to show the relationship between x and y. What we see now, though, is we can actually represent the same relationship only using an inequality. So instead of y equals mx plus b, I can have y greater than mx plus b. Now I've got something that's unequal. I still have a relationship between x and y, but now there's an inequality defining that relationship. Same thing, I can also put it in standard form. I could have ax plus by is less than or equal to c. I can use any of the four inequalities that I have: greater than, less than, greater than or equal to, less than or equal to. And that's what we're going to be getting into throughout this whole unit, is dealing with two variables, x and y, but looking at how do they relate in terms of an inequality relationship. All right, let's pick an example of an equation here. Y equals 5x minus 3. That's a nice linear equation in slope-intercept form. We're going to evaluate it for when x equals 1. So that means I substitute 1 in for x, and we're going to solve to see what y equals. So 5 times 1, I'm going to put that in there, minus 3. Well, 5 times 1 is 5, and minus 3. When I evaluate the whole side on the left there, 5 minus 3 is 2. So we've solved it out. We've got y is equal to 2. Now, I can rewrite that knowing that x was 1 and y is 2. I can write that as an ordered pair with the x value first. X is 1, y is 2. That's a point I can plot on a graph. And it's one solution. So we evaluated for that one particular y value. We get one particular x value gives us that one particular y value. And we have 1 point for a solution. All right, now let's take that same thing, but let's make it an inequality. Let's do y is less than 5x minus 3 and just kind of play around with it and see what happens. So I'm still going to evaluate that inequality at x equals 1. But now let's see what we have here. So we've still got y is less than 5 times 1 minus 3. And if I solve all that out, 5 times 1 is 5 minus 3. We still get 2. So we got y is less than 2. Well, now what does that mean in the inequality then? Well, what are values that are less than 2? Well, y could be 1. Y could be 0. Y could be negative 1. Y could be negative 2. And it goes on and on. There's an infinite amount of values that y could be. They just have to be less than 2. Well, using just those ones I found, I can use the x value of 1 and the various y values that work, and I can write a whole series of points. So one solution to that inequality is 1, 1. One solution is 1, 0. One solution is 1, negative 1. One solution is 1, negative 2. These, for an all x value of 1, those are all y values that work. And so I have 4 different points that are all solutions, and there's an infinite amount because I can keep going. I can keep finding other y values just for that particular x value. So as we're working with inequalities, we're going to be dealing with cases where we have an infinite number of solutions. and learning about how to represent those solutions, how to work with writing out sets of solutions, being able to rearrange and work with linear inequalities. So hopefully this is a good introduction for you, especially comparing what we've already done with linear equations and kind of thinking about, well, now it's a linear inequality. How do I think about inequalities, infinite solution sets, greater than and less than, all that good stuff.